First of all, I'd like to congratulate all members of the Academy of Sciences of Moldova on the 60th anniversary of their very distinguished academy. In this regard, I want to make personal thank to Professor Tăgăneanu, President, for inviting me to present a public lecture, and Professor Boris Boanchan, who is a dear friend and a great scientist, very distinguished global scientist on the journalism and their sustainable management. The topic of my discussion, as suggested by Professor Tăgăneanu, is soil health in the age of global warming, importance for the sustainable development of society, especially in the post-pandemic human health period. I would like to mention the pandemic case globally. India, amongst the developing country, has been hit very hard by second wave. So far, 26 million affected, almost 300 deaths. US, 33 million people affected, almost 600,000 deaths, and globally, 166 million people affected and 3.5 million deaths. Moldova, although a small country, has a very similar situation. But we want to talk about the Green Revolution in the context of food security issues going back to 60s and 70s. Between 1961 and 2020, the global population increased by a factor of 2.5, from 3.1 billion to 7.8 billion. Global cereal production increased by a factor of 3.3, from 880 million tons to 3 billion tons. Therefore, the per capita cereal production increased 32%, from 284 kilograms per person to 376 kilograms per person. And this remarkable success story can appropriately be called the Borlaug effect, after Norman Borlaug, who ushered in the Green Revolution, along with many of other colleagues, such as Professor Swaminathan. However, the Green Revolution was input-based. The nitrogen fertilizer used globally over the same period increased by a factor of 9.2. The nitrogen fertilizer used in the world now is 200 million tons. Phosphorus fertilizer went up 5 times, potassium also 5 times, pesticides dramatic increase, irrigation went up 2.4 times, from 144 million to 350 million hectares. The green evolution based on varieties and inputs led to soil degradation. Globally, 1/3 of all soils, ice-free land, 3.5 billion hectares or more, is degraded by processes such as soil erosion by water, soil erosion by wind, affecting 1 and 0.6 billion hectares respectively, salinization almost 1 billion hectares, of which 20% of all irrigated land is prone to secondary salinization. And the sediment load in the rivers of the world has been estimated at 36 gigaton per year, compared with about 14-15 gigaton per year in the pre-industrial era. And the so-called carbon civilization has also contributed tremendously to global warming through anthropogenic emission from land use change and fossil fuel combustion. Prehistorically, from 1750 before, from the beginning of agriculture 10,000 years ago to 1750, about 320 gigaton came from land use change, deforestation, biomass burning. And from 1750 to 2018, 2019, another 235 gigaton. So total about 555 gigaton. Compare that with fossil fuel emission from 1750 to 2018, 440 gigaton emitted. So if you combine 235 with 440, 675 gigaton anthropogenic emission since 1750, 75% fossil fuel, 25% of land use change has already increased global temperature by 1.1 degrees centigrade, and the future rate of increase is 0.2 degrees centigrade per decade. the global warming, a very serious environmental issue, which obviously agriculture has quite a lot to do with it, because 33% of all greenhouse gases directly or indirectly come from agriculture. Consequently, the Sustainable Development Goals are not on track. Sadly, unfortunately, regrettably, with good intention, but in another 9-year period from now, by 2030, Sustainable Development Goal number 2, ending hunger, number 13, climate action, number 15, achieving land degradation neutrality, along with number 1 of ending poverty, achieving good health of all human, improving clean water, and having renewable energy. None of these are on track to achievement. Yet, proper, judicious, prudent management of soil, restoration of soil health, recarbonization of the soil and the biosphere can put these Sustainable Development Goals on track to achievement, to accomplishment. And that should be done. That brings me back to the COVID-19 issue, Professor. Tagignano suggested that a talk in the context of Moldova pandemic, similar to the other countries I mentioned, India, US, and the world. Moldova, although a small country, has undergone 2 peaks already, one in November last year and one in April, May this year. Consequently, the population affected 255,000, of which 6,000 lost their life. And compare that with the US and the world, of course, it is Moldova. Fortunately, it is a very small number and can still be smaller. But in the context of food security, globally, about 690 million people are food insecure. Another 2 billion are malnourished. But pandemic has increased the number of food insecure people by another 130 million, including those in Moldova, some, including in the US. And this concern must be addressed by the Green Revolution and by other strategies to make sure that the local food production system, are strengthened and made more resilient by different type of green revolution. A green revolution which is based on solar resilience, which is based on eco-efficiency of inputs. It's based on science and management concept of producing more from less through soil health improvement. And soil health improvement, an important part of that is carbon sequestration in soil. The process of carbon sequestration implies restoring the depleted soil carbon stock, both organic and inorganic, through recommended land use and soil management practices on a landscape unit by transfer of atmospheric CO2 to the input of biomass carbon as soil humus, and by production of secondary carbonates as soil inorganic carbon sequestration. And from this point of view, we must consider that soil carbon stock has 2 distinct but related components. It's the soil organic carbon, which has a different components of it, and soil inorganic carbon, which is pathogenic or secondary carbonate. And there's a relationship between inorganic and organic, because the decomposition of organic matter, the respiration of the microorganism, leads to emission of CO2 in the soil, and CO2 can dissolve in soil water and make carbonic acid that precipitates with reaction with calcium, magnesium, potassium, etc. When they are added through lime and through compost, manure, etc., can precipitate to lead to formation of secondary carbonates, which look like chalkish white material in soils of the semi-arid region, including chernozums, which you can see very distinctly against the dark background, the white, either nodules or sheets of secondary carbonates deposited on the surface of on the surface of the soil. And these are very predominant in soils of the arid and semi-arid regions. In terms of chemical reaction, the aluminosilicates, like aluminum silica complex, they react with CO2 from the atmosphere and lead to formation of carbonates. And over a millennial time scale, geologic time period, these reactions lead to stabilization of climate and sequestration of carbon dioxide from the atmosphere into the soil. A simple reaction, CO2 plus calcium silicate or CO2 plus magnesium silicate, and leading to formation of calcium carbonate, magnesium carbonate, can be accelerated by creating a powder of soft minerals such as olivine and spreading it on the soil as a lime. And therefore the reaction can be increased and CO2 from the atmosphere sequestered as calcium or magnesium carbonate, a practice which is being recommended. Soil organic matter content, which is a sequestration of soil organic carbon, is a very important component of soil health. In fact, it has 4 parts: fresh residue, active fraction, stabilized fraction, and living organism is a symbol of life. A healthy soil must have 5 metric ton of living biomass in the soil per hectare. Because soil and life, they are very intricately interconnected. Charles Kellogg of USDA in the 40s and 50s made a very profound statement: there can be no life without soil and no soil without life. They have evolved together. Following up on that very important concept, I have suggested that rhizosphere, the soil root interface at nanoscale, is the only proven place in the universe where the death is resurrected into life. In fact, there is no death in nature. Death and life are one continuum. They are 2 sides of the same coin, and the coin happens to be soil, where the death of the living organism, their death and their decomposition releases nutrients absorbed by plant roots and begin the life all over again. A healthy soil must have 5% of organic matter content and biota, which amounts to about 5 metric ton per hectare. And therefore, soil health is defined as a soil's capacity as a dynamic and biologically active entity within natural managed landscape to sustain multiple ecosystem services such as food security, water quality, biodiversity, climate regulation, elemental cycling, so that these ecosystem services can be strengthened both for nature and human. And this concept of soil health is more important now during the pandemic than ever before because of the need to strengthen the local food production system, the local food production system. The disruption in international and national level supply chain caused by pandemic can be overcome by strengthening of the local food production systems. Home gardens, urban agriculture, peri-urban agriculture, small plots. I was very impressed by small plots of each professor at the University of Caruso University. That kind of concept need to be applied universally so that the food supply chain at a local level can be strengthened. And the other part, which is very important, is implication of the One Health concept. And the One Health concept says the health of soil, plants, animal, human, environment, ecosystem, and the planet is one and indivisible. Therefore, if the health of soil is degraded by land misuse and soil mismanagement, cutting corner for making quick economic returns, not taking soil health properly and judiciously, the degradation of soil health can also degrade everything else. That brings me to another concept, that people are mirror image of the soil they live on. When people are miserable, hungry, suffering, they can pass on their sufferings to the land, and unfortunately, the land reciprocates. And this is a vicious cycle. And this vicious cycle can only be broken through an entry point, which is soil health, through management of organic matter content. Because soil organic matter content, when it's at above the threshold level of 4 or 5%, it generates many ecosystem services: water quality, water renewability, climate change adaptation mitigation, food and nutritional quality and safety, and the biodiversity, both above and below ground, because soil organic matter is the heart of soil health. And this concept is now more important. We need to bring about a strong buffer between human and nature, and soil health and its sustainable management provides us that buffer by producing not only more food, but by producing more and nutritious, healthy food. So people are healthy and they can resist the invasion of organisms. So the difference between the green revolution of the 60s and the green revolution now, which is soil-centric, soil health-based, soil organic matter-based, plant structure is different. We were talking about dwarf variety at that time, low biomass, low root growth. We are talking about high biomass, high root growth, as well as high harvest index. But high root biomass and high shoot biomass are very critical, because that is where the carbon sequestration will happen. And the plant should be able to adapt to the climatic conditions under global warming, especially the drought, especially some of the pest and incidents. And from the pest and incident point of view, no-till farming, cover cropping, especially cover cropping, and improving soil biodiversity so that soil becomes disease suppressive. Healthy soils are disease suppressive soils. They have predators and who can suppress the pathogens and other organisms that cause plant diseases. And then you try to integrate the crops with trees and livestock. So you have a holistic approach to soil management. And if we need to add some nutrients and water, they should be applied directly to plant roots, only needed when needed, and proper rate and proper mode of application. So they are absorbed by the plants and not leak into the environment. Not leak into the environment. That leakage into the environment has created serious issues globally. Algal bloom, N2O emission, eutrophication, air pollution. That is why we need to be very precise in what is applied and how it is applied. And the concept that Professor Boris also put in his book on Chernosm, CNPK. C, carbon, recycling, biomass, mulch farming, cover cropping, compost, before NPK. If we have adequate amount of C through mulch and through cover cropping, the need for NPK over time will become less and less, and its use efficiency is also improved. And by having that formula CNPK, soil organic matter content increases, water retention characteristics of the PF curves of the soil are also better. Here's a PF curve of a soil rich in organic matter content and same soil which is depleted of its organic matter content. Notice the inflection point. Notice the difference between moisture content at low suction, such as at field capacity. So field capacity moisture content in soils with organic matter content is much higher than the field moisture capacity in soil without organic matter content. Therefore, the available water holding capacity is much greater. So plants grown in a soil with more organic matter content can resist drought. And there is a saving in water, just like saving in nitrogen, phosphorus, potassium and other nutrients by improving the organic matter content. The strategy is of eco-intensification, producing more from less land, less water, less fertilizer, less pesticide, less energy, less emission of greenhouse gases, less wastage, less leakage into the environment. And in terms of irrigation, the idea is producing more crop per drop. Remember, I said 350 million hectare under irrigation with the flood mostly. And if we use micro irrigation, drip irrigation, we can have precision irrigation, we can deficit irrigation, we can improve the quality of soil and water, along with combination of biological nitrogen fixation, nutrient cycling, we can save the resources. And there's an optimal range of organic matter content for every soil to produce optimum yield. And here's an example of wheat production from the Pampas region in Argentina. The organic matter content increases over time with management, and therefore the wheat yield goes up, and the optimum level is about 40 to 50 metric ton per hectare of organic matter content. I did some research and calculated that if you can increase the organic matter content in cropland soils of the world by the rate of 1 ton per hectare, you can increase crop production of cereal globally somewhere between 22 and 36 million tons, legumes about 2 to 3 million tons, roots and tuber about 7 to 11 million tons, total about 30 to 50 million tons. If you can increase the by 10 tons per hectare over a 10-year period, multiply that number by 10. It's not always linear, but approximately. What it tells you is that how production can be increased without the inputs of chemicals by restoring soil health and soil organic matter content. A very important concept. And the rates of carbon sequestration in Chernosem, Professor Bonchan and his team has determined globally somewhere between 300 to 500 kilogram per hectare per year on cropland, maybe 500 to 600. In some ideal condition, maybe 1 ton, 1,000 kilogram per hectare. If you restore wetlands, the rate of sequestration may be 1,500 kilogram. By restoring trees, afforestation, the soil carbon rate may be 1 ton, the vegetation, another 1 ton. No-till farming, about 500 kilogram, and rangeland management, about 200, 300 kilogram. The idea is to growing carbon as a farm commodity so that the carbon stored in forest biomass and soil can bring another income for farmers. And that income is very important, especially in developing countries, because farmers, their poverty, rural poverty is an issue. Sustainable Development Goal number 1, and poverty by 2030. So if farmers can be compensated through payment for ecosystem services, and my suggestion for payment is $130 per ton of carbon, which comes to $35 per ton of CO2, which means if a farmer sequesters half a ton in trees and soil, they should be compensated $65 per hectare per year, or $26 per acre per year. If they sequester 1/3 ton, $43 per hectare, or $18. Who pays this? Development organization. Obviously, consumers. But I'm thinking more from industry, the private sector, the agro industry. They have a stakes at improving the productivity, restoring soil health. They compensate farmer. If you do better agriculture, we will compensate you. Of course, they are trying to sell product, maybe seed quality, maybe soil amendment, maybe compost, maybe tractors, maybe irrigation equipment, many others produce for which they can compensate farmers. The rate of carbon sequestration in soils of the world can be as much as 2 tons, 2 gigaton, petagram, gigaton per hectare. Remember, the rate of fossil fuel emission is 10 gigaton. So soil carbon alone is a good thing, but not enough. So we must find alternative to fossil fuel. If we can find alternative to fossil fuel by 2050, and we begin sequestering carbon in soils of the world somewhere between 2 to 2.5 gigaton per year, yes, climate change can be controlled to within 2 degrees centigrade. Yes, it is possible. I estimated, published an article in 2018 that the rate of sequestration for all soils of the world, including degraded land, can be as much as 2.5. So between now and 2100, soils of the world can sequester 178 petagram, gigaton of carbon. Vegetation sequester 155. Total combined vegetation soil about 330 petagram, which is a drawdown of atmospheric CO2 of 157 parts per million. If we stop further emission, hopefully soon, by finding geo, wind, hydro, bio, many other forms of solar especially, climate change control is still in our reach. We can still do that. And by doing that, by improving soil health, we are right now cultivating a lot of land area. We are cultivating 5 billion hectares of cropland, of which 700 million hectares is of cereal land. This land area under cereal production, rather than increasing it, as many people suggest, it should be decreased over time by as much as 200 million hectares. Similarly, rangeland can be decreased from 3.5 billion hectares to perhaps 2 billion hectares or 2.5 billion hectares. Fertilizer use, right now 200 million tons with soil health improvement, should progressively be reduced. Pesticide reduced. Irrigated land area increased, but water use reduced, and yet the crop yield can be doubled. And I showed you how impact of soil health on that was. So this way we can return land, water back to nature. My goal, my suggestion, and I'm writing an article on this topic right now, is how to return 1.5 billion hectares of land between now and 2050 back to nature. And that way there's a buffer between nature and human, so that the pandemic risks, such as we are suffering now, can be less and less. We live in harmony with nature. We live in symbiosis with nature. Our goal is not to conquer nature. Our goal is to be pro-nature. Pro-nature. That's what we want to be. And for that, I've been suggesting a trinity of legal rules, laws. Take the example of the United States. Soil health is like the top of a stool. Through agricultural sustainability and rights of soils. And we have Clean Air Act of 1967. We have Clean Water Act of 1972. It's a time to have a Clean Soil Act, Healthy Soil Act. For this, you need prudent governance, appropriate policy, payment to farmers for ecosystem services, compensating farmers, making our agricultural policy pro-nature, pro-agriculture, pro-farmer, and pro-poor. We must raise the stature, professional stature of farmers and farming profession at all levels. And 60% to 70% of farmers in developing countries of Africa, Caribbean, and South Asia, Southeast Asia are women. Therefore, we must empower women farmers and farmers. Professor Gnanu and colleagues, Professor Bonchan, thank you for the opportunity for the lecture. I wish you a great celebration for the 60th anniversary, and I'll be delighted to answer any question that you may have. Thank you.